This is the first class of Industrial Hydraulics, Module 1. Module 1 consists Introduction to Fluid Power, Classification of Fluid Power, Hydraulic System, Pneumatic System, Hydrostatic and Hydrodynamic System, Advantage, Disadvantage and Application of Fluid Power. Then 1.2 Component of Hydraulic and Pneumatic System, Comparison of Hydraulic and Pneumatic System. Then 1.3 Properties of Fluids. 1.4 Hydraulic reservoir, hydraulic filter, factors influencing selection of hydraulic fluid, additives in hydraulic fluids, types of hydraulic fluids, etc. Okay, so we are starting first module. First, types of power transmission in an industry. There are three modes of power transmission in industry: mechanical transmission, electrical transmission, and fluid power transmission. Mechanical transmission is through belt drive, gear drive, chain drive, etc. And electrical transmission through wire and transformer. And fluid power transmission through pressurized fluids. These are three modes of power transmission in any industry. Power transmission means that may be a linear power or a rotary power that will be transferring from one point to another point. So there are three modes of power transmission: mechanical transmission, electrical transmission, fluid power transmission. So here in this subject, we are going to discuss with the fluid power transmission. See, fluid power transmission, that is classified into two types: hydraulic power and pneumatic power. So what is the definition of a fluid power transmission? So this definition you have to remember. Fluid power is a technology that deals with the generation, control and transmission of forces and movement of mechanical elements with the use of pressurized fluid in a confined space. Fluid power is basically a technology that deals with the generation of power, control and transmission of forces and movements of mechanical elements with the use of pressurized fluid in a confined space. Confined space is very important. In open space, power is not transmitted. So this is the definition of the fluid power. Fluid power is a technology that deals with generation, control and transmission of forces and movement of mechanical elements or system with the use of pressurized fluid in a confined space. See, this fluid power is classified into two types: hydraulics and pneumatics. In fluid power, the working fluid is either pressurized hydraulic oil or compressed gas. See, in hydraulic system, the working fluid is pressurized hydraulic oil, and pneumatic system, the working fluid is compressed gas. See, in any hydraulics and pneumatic system, so hydraulic system deals with the pressurized hydraulic oil, pneumatic system deals with the compressed gas. See, in any fluid power system, there is a mechanical device that energizes the working fluid or fluid. That device is known as, in the case of hydraulics, it is known as hydraulic pump. In the case of pneumatics, it is known as compressor. So hydraulic pump means, hydraulic pump is a mechanical device that is used in the hydraulic system to energize the hydraulic oil or pressurize the hydraulic oil. And compressor, that is another mechanical device which is used in pneumatic system, which energize the gas or air, compress the gas or air. Then second important device in a hydraulic system and pneumatic system is the actuator. See, actuators are the mechanical device that actually deliver the work output. Work output may be a linear motion, force resulting linear motion, or a torque resulting rotary motion. See, these actuators are classified into two types: cylinder and motors. Cylinder, that will always produce force resulting linear motion, and motors that will produce torque resulting rotary motions. That's the difference between cylinder and motors. So in the case of hydraulics, the actuators are classified into hydraulic cylinder and hydraulic motors. So hydraulic cylinder that produce force resulting linear motion and hydraulic motors that produce torque resulting rotary motions. So that's an introduction about the industrial hydraulics. So here in this subject, completely discussing with the hydraulic systems, not pneumatic system, hydraulic systems. So let's one. What is the basic principle of a hydraulic system? Pascal law is the basic principle of hydraulic system. What is Pascal law? If a certain pressure is applied to any point in a static fluid, then it get equally transmitted in all directions to every other point in a fluid. That's important point. If a certain pressure is applied at any point in a static fluid, then it get equally transmitted in all directions and to every other point in the fluid. So for an example, this is a hydraulic chamber. Here area will be A1 and here area will be A2. So if you are applying F1 force here, F2 force that will be producing, and the pressure developed will be the F2 force will be greater than F1 as the area will be A2 will be greater than A1. So this Pascal law is commonly used in the hydraulic jack. So you can see that here the force producing here will be very much greater than the force applied here due to the area difference. Okay. See, what's the important point of Pascal law is Pascal law is valid only under hydrostatic system. That's the important point. Pascal law valid only under hydrostatic system. Hydrodynamic system Pascal law is not valid. Okay. So that's the concept of Pascal law. This Pascal law, there's a chance that for a 3-mark question will be in Pascal law. What's the basic principle of hydraulic system, or explain Pascal law, etc. So you have to write this point and you have to draw the figures also for getting full mark. Up to this you have to write. Okay. So next one is hydrostatic system and hydrodynamic system. In fluid power, there are two systems, hydrostatic system and hydrodynamic system. See, hydrostatic system uses fluid pressure to transmit power. So hydrostatic and hydrodynamic system both uses fluid power to transmit power. Hydrostatic system deals with the mechanism of still fluid and uses the theory of equilibrium condition. See, in hydrostatic system, the fluid is filled in a confined space. The fluid is not flowing. So mechanism of still fluid is using, theory of equilibrium condition is using. Example is hydraulic jack. In hydraulic jack, the oil is filled in a confined space. So in hydrodynamic system, power transmitted by the kinetic energy of the fluid. It deals with the mechanism of moving fluid and uses flow theory. Example is hydraulic turbine. How power is produced from hydraulic turbine? By utilizing kinetic energy of the flowing fluid. So that's the difference between hydrostatic system and hydrodynamic system. So hydrostatic system, in the case of hydraulic system, we are using hydrostatic system to transmit power from one point to another point. Okay. So this is also a 3-mark question. Very important question. What's the difference between hydrostatic system and hydrodynamic system? First one is fluid power system and fluid transport system. What is the difference between fluid power system and fluid transport system? Both of them are different. So first of all, fluid transport system. See, the sole objective of a fluid transport system is transport fluid from one point to another point, or one location to another location. For example, pumping water to residential area. Here, the objective is to transport the fluid from one location to another location. There is no power work output will be producing utilizing that fluid. In fluid power system are designed to perform a work. The pressure energy of the fluid is utilized by the actuator that will be producing a work output. So high pressurized fluid acting directly on a fluid cylinder or a fluid motor and producing the work output in the case of fluid power system. So fluid power system, we have hydraulic cylinders and hydraulic motors. Hydraulic cylinder that will produce linear motion, force resulting linear motion, and hydraulic motors that will produce torque resulting rotary motion. Okay, so that's the difference between fluid transport system and fluid power system. See, this is an important 3-mark question. Explain the difference between fluid transport system and fluid power system. Difference between fluid transport system and fluid power system. You can expect a 3-mark question from this area. Explain the difference between fluid transport system and fluid power system. Okay. So what are the application of a hydraulic system? See, hydraulic systems are commonly using in agriculture, tractors, harvesters, automobile, power steering, power brake. In power steering, we are using hydraulic system, and power brake, we are using hydraulic system. Aviation, landing wheel in aircraft, aircraft trolleys, glass industry, vacuum suction cup for handling, construction industries, excavator, bucket loader, road cleaner, defy industry, missile launching system, machine tools, automated machine tools, newspaper industry, edge trimming, pressure, bundle warping, medical industry, bottle filling, tablet placement, hospital bed, plastic industry, injection molding system, raw material feeding, etc. So this is also an important question. What are the application of the fluid hydraulic system? There may be chance that the question asking like application of hydraulic system. You have to write only the points. That is agriculture, tractor, harvesters, automobile field, power steering, power brake, aviation, landing wheel in aircraft, aircraft trolleys, glass industry, vacuum suction cup for handling, construction industry, excavator, bucket loader, road cleaner, defy industry, missile launching system, machine tool, automated machine tools, newspaper industry, edge trimming, pressure bundle, warping. So you have to write that points only. Okay. So what's the advantage of fluid power over electrical and mechanical power transmission? That's a very important question. What's the advantage of fluid power, electrical power, and mechanical power transmission? In fluid power transmission, force or torque can be held constant. It is not varying. This is the unique to fluid power transmission, high torque at low speeds. In fluid power transmission, force or torque can be held constant throughout the working, and high torque will be producing at lower speeds. So pneumatic and hydraulic motors can produce high torque while operating at lower rotational speed also. Some fluid motors can even maintain torque at zero speed without overheating. So this is a unique feature of a fluid power system when comparing to mechanical or electrical transmission. So this is also the advantage of a fluid power system over mechanical or electrical transmission. Okay. So next one is basic components of hydraulic system. These you can accept this question as a essay, that is basic components of hydraulic system and basic components of pneumatic system. So first of all, basic components of hydraulic system. See, this is a figure. See, in this subject, figure is very important. 50% of the mark will be awarded for figure. So you have to draw the figure and write points. So figure should be drawn neatly. Half of the mark will be awarded for 50% of the mark will be awarded for the figure. So what are the components of a hydraulic system? This is you can expect as a essay question, very important question. Explain the components of hydraulic system. See, the schema diagram explain the components of a hydraulic system. The main components of a hydraulic system are hydraulic reservoir, hydraulic filter, pump connected to a electrical motor, pressure regulator, direction control valve, actuator, hydraulic actuators. So we can discuss one by one what are the functions of each component in a hydraulic system. First one is hydraulic reservoir. See, hydraulic reservoir, which is used to store the hydraulic oil. It is also known as oil tank, etc. The purpose of hydraulic reservoir is storing the hydraulic oil. Next one, hydraulic filter. See, hydraulic filter that will iterate the impurities and foreign particles or removing the impurities and foreign particles before the hydraulic oil reaching into pump. Next one, pump. So actually pump is a mechanical device which convert mechanical energy into hydraulic energy, which pressurize the hydraulic oil. When low pressure hydraulic oil flowing through the pump, it is converted into high pressure. Commonly post displacement pump are highly using in the case of hydraulic system because post displacement pump are high head low discharge pump, example gear pump, piston pump, etc. See, pressure regulator regulate the pressure of hydraulic oil which can be utilized by the actuator. So pressure regulator control the pressure energy of the hydraulic oil that is utilized by the actuator. So next one important component is direction control valve. See, direction control valve control the direction of motion of the actuators. So this is a linear actuator. Linear actuator means linear actuator that produces force resulting linear motion. So this actuator have a upward movement, downward movement, and load can lift and stay at a particular height. There are three motions are available for this hydraulic actuator. So direction control valve that will control the direction of motion of the actuator. Suppose this is a P port and this is T and this is A and this is B. So these are the four ports are available for this direction control valve. This is P. P means pressure line port which is connected to pump. T is return line port which is connected to tank. And AB are working line port which is connected to the hydraulic actuator. So for lifting the load, the port P is connected to port B and port A is connected to port D. So highly pressurized hydraulic oil that flow through port P to port B and flow to the piston side of the hydraulic cylinder. So this is the piston side and this is the rod side. So highly pressurized hydraulic oil exert a pressure over the piston and the piston move in upward direction. At the same time, the hydraulic oil in the rod side of the cylinder that flow through port B to port T to the reservoir. Suppose the actuator has to move downward direction. The port P is connected to port A, port B is connected to port T. Then high pressurized hydraulic oil flow through the port P to port A to the rod side of the cylinder and exerting a pressure of the piston moving downward direction. At the same time, the hydraulic oil in the piston side of the cylinder flow through port B to port T to the reservoir. So if you want to hold the load at a particular height, that's the third position, P and T will be connected. Port P and T will be connected. And port B, A and B are closed. So there is no flow of hydraulic oil to the working line ports. Port P and port T will be connected in this way. Port A and port B are blocked. So hydraulic oil is not flowing to the working line port. So in this way, direction control valve control the direction of motion of actuators. So direction control valve are used to control the direction of motion of the actuators. A last component in a hydraulic system is the actuators. What is the function of an actuator? See, in actuator, the hydraulic energy is converted into mechanical energy. In pump, mechanical energy is converted into hydraulic energy. In actuator, hydraulic energy is converted into mechanical energy. Okay. So actuator, hydraulic actuators have linear actuator and rotary actuators. Rotary actuators are known as motors, hydraulic motors. So linear actuators that will produce, linear actuators are hydraulic cylinders. So hydraulic cylinder that will produce force resulting linear motion, and hydraulic motors that produce torque resulting rotary motions. So these are the components in a hydraulic system. So we have hydraulic reservoir, filter, pump, pressure regulator, direction control valve, then hydraulic actuator. So you have to draw this figure and explain the details. Figure have almost 50% of the mark will be awarded for figure. Okay. Then next one, explain the components of a pneumatic system. What are the components of a pneumatic system? See, what's the importance of a pneumatic system? In the case of pneumatic system, the working fluid is pressurized air, compressed air or gas. That's the important point. Working fluid is compressed gas or air. See, what are the various components in a pneumatic system? Air filter, compressor, air cooler, storage reservoir, FRL unit, direction control, pneumatic actuator. Okay, so these are the main components in a pneumatic system. So in a pneumatic system, reservoirs are not present actually. Same like as a hydraulic system. Hydraulic system have a reservoir, but in pneumatic system there is no reservoir not found. See, what's the importance is in pneumatic system, air is sucking from the surrounding atmosphere. So there is no reservoir needed as hydraulic system. So here, first component is air filter. See, air filter, what's the purpose of air filter is, which is used to filter the air and remove any impurities and foreign particles that will be present in the air. Next one is compressor. So compressor that energize the air or gas. Compressor is attached to a prime mover, that is electrical motor. Whenever the low pressure air passes through compressor, it will get energized, converted to high pressure. Air cooler, next component is the air cooler. During the compression process, there is a chance that the temperature of the air will be getting increased. So actually adiabatic compression will take place. Adiabatic compression that will always increase the temperature. So the temperature of the air will be increased. So that high temperature air will affect the sensitive components in the pneumatic system. So in order to reduce the air is passing through an air cooler. Next one will be storage reservoir. See, storage reservoir that are commonly used to store the high pressurized air, which will store in the high pressurized air. Compressor is not working continuously. Compressor will be working whenever we require. Other times the storage reservoir will store the compressor. From that storage reservoir, actuator will take the air. So next one is the FRL unit. That's an important unit in pneumatic system. FRL unit means filter regulator lubricator. That is a FRL unit. That consists of a filter which will filter the air again, then a regulator which will regulate the pressure, and a lubricator that will provide some lubrication oil. So that is the FRL unit. So FRL unit is filter, F means filter, R means regulator, and L means lubricator. Filter means which will filter the air. Regulator means which will control the pressure. Then lubricator means it will provide some lubrication to air. Then we have direction control valve. So direction control valve which is used to control the direction of motion of the actuator. So we have already discussed the purpose of direction control valve in hydraulic system. The same way here also using the direction control valve. So this is a 4-port direction control valve. We have P, these port are P and T, pressure line port, return line port. T is return line port. A and B are working line port. So by using this direction control valve, three positions can be achieved the actuator. That means lifting the load, lowering the load, and lifting the load and placing at a particular height. So direction control valve are commonly using to control the direction of motion of the actuator. See, the most widely using direction control valve in the case of a pneumatic system is 5x2 direction control. 5x2 direction control valve means 5 port 2 position direction control. This is a 4x3 direction control actually. 4 port 3 position direction control. Then last component in pneumatic system is air actuator. So what's the purpose of an air actuator? Which will convert pressure energy of the air into mechanical energy. So these air actuators are classified into air cylinder, and pneumatic motors. Pneumatic cylinder that produce linear motion, force resulting linear motion. Pneumatic motors that produce torque resulting rotary motions. So these are the components in a pneumatic system. So we have air filter, air compressor, air cooler, storage reservoir, FRL unit, then direction control valve, then air actuator. So FRL unit means filter, regulator, lubricator unit. Okay, so this is also a very important question. There is a chance that explain with the neat sketch what are the main components in a pneumatic system and all what are the main components in a hydraulic system. Okay. Just comparison between hydraulic and pneumatic system. Another important topic. Comparison between hydraulics and pneumatic system. So you have to write in this way only. You have to compare the hydraulic system and pneumatic system. So first of all, it employs pressurized liquid. In hydraulic system, employs pressurized liquid, pressurized hydraulic oil. It employs a compressed gas, usually air as the fluid. Second point, an oil hydraulic system operate at a pressure up to 70 bar. Only up to 70 bar hydraulic system work. A pneumatic system usually operate at 5 to 10 bar. So hydraulic system can produce high pressure when compared to pneumatic system. Pneumatic system only operate at 5 to 10 bar. Hydraulic system generally designed as a closed system. The hydraulic oil that will be flowing from hydraulic reservoir and after flowing through several components and finally return to hydraulic reservoir. That's why it is known as closed system. Pneumatic system is generally designed as an open system. Open system means the air is taken from atmosphere and air is after producing the work output, air is go to the atmosphere. The system slow down when leakage occur. In pneumatic system, if there is any leakage will be there, the system slow down. But in hydraulic system, leakage does pneumatic system. In hydraulic system, slow down when leakage occur. But in pneumatic system does not affect the leakage does not affect the system much. Valve operations are difficult in hydraulic system. Valve operations are easy in pneumatic system. Heavier in weight in hydraulic system is heavy weight. Pneumatic system are lightweight. In hydraulic system, pump are used to provide pressurized liquid. In pneumatic system, compressor are used to provide compressed gas. The system is unsafe to fire hazard in hydraulics. The system is free from fire hazard. Automatic lubrication provided in pneumatic system, special arrangement for lubrication are needed. That is known as FRL unit. So these are the difference between a comparison between hydraulic and pneumatic system. That's a very important question. This comparison between hydraulics and pneumatic system. Once more we can discuss. In hydraulic system, it employs pressurized liquid. Pneumatic system, it employs a compressed gas, usually air as fluid. In hydraulic system, operates at a pressure up to 70 bar. Pneumatic system usually operate at a 5 to 10 bar. Hydraulic system generally designed as closed system. Pneumatic system generally designed as open system. The system slow down when leakage occur. In hydraulic system, the system slow down when leakage occur. But leakage does not affect the system much in pneumatic system. In hydraulic system, valve operations are difficult, but in pneumatic system, valve operations are easy. Hydraulic system is heavier in weight when compared to pneumatic system. In hydraulic system, pump are used to provide pressurized liquid, but in pneumatic system, compressor are used to provide compressed gas. Hydraulic system is possible chance to fire hazard, but in pneumatic system, there is no chance of fire hazard. In hydraulic system, automatic lubrication is provided. In pneumatic system, there is separate arrangement for lubrication and needed. So this is a comparison between a hydraulic system and pneumatic system. So we can wind up the class now. So in this section, we are discussed with the basics of hydraulics. What are the different mode of power transmission in an industry? What's the definition of a hydraulic power, fluid power? Fluid power is classified into hydraulics and pneumatics. What's the importance of pump and compressor and actuator in a hydraulic and pneumatic system? Pascal law and importance in hydraulic system. Hydrostatic and hydrodynamic system. Then fluid transport and fluid power system. What are the components in a hydraulic system and what are the components in a pneumatic system, and comparison of hydraulics and pneumatic system. Okay.